afterwards. So our first application is forecasting. So one of the main things that people say with my area of AI, which is machine learning specifically, is we want to be able to forecast. We want to see into the future. We often have analytics and they often tell us what has happened yesterday, what happened last month, sales volume, manufacturing, things like that, looking backwards. And then we take action and then we're reacting to things that have already happened. What we want to do with machine learning, start learning from the past and predicting that forward, so then we can start taking reactive steps moving forward. So many different algorithms for predictive analysis, and essentially what they do is they take one or more inputs to predict an output. So for our first use case, I want you to imagine that you own a large consumer electronics store, something like Currys, and you're thinking, right, well, we want to optimize our warehouses, we want to optimize our staffing schedules, we want to do all of this, but we can't do that without looking forwards a little bit. So we need to know what we're going to sell on Saturday so we can get the TVs into the warehouse so that they're available in stock, so on and so forth. How many members of staff do we need? Things like that. And we can optimize the store accordingly. So if you want to start predicting sales volume, so you look forward and think, well, on next Saturday, how much am I predicted to sell? On Tuesday afternoon, how much am I predicted to sell? Well, what we can do is we can take an input or more inputs and we can predict that output. So if the output is sales volume, what can we do for the input? So an input we've taken into account here is what we call occupancy. So as you can imagine, as occupancy goes up in store, your sales volume is probably going to follow it. So that's something we call positive correlation. So the more people in store, the more they buy, sales volume goes up. Fairly standard stuff. So what we can do is we can track occupancy over the last year, 5 years, 10 years, whatever data you've got available, and we can project that forward. How does that look in reality? So it looks a little something like this, which is probably, if you've done GCSE maths, it probably looks something very similar with a line of best fit. So you've plotted your occupancy along the bottom, you've got your sales volume along the top. So that's your historical data. And as you can see, it's positively correlated, which means as occupancy increases, sales volume also increases. So then you can use that and you can get machine learning to draw that line of best fit and then project that forward. So if you say on Saturday, I'm anticipating we're going to get 100 people into store, what does that look like? Okay, we're going to sell about £12,000 worth of stuff. So, okay, well, for £12,000 worth of sales volume, we need 8 members of staff. We probably need TVs in, fridges in, things like that. You can also do this on a SKU by SKU basis, so it doesn't have to be overall sales volume for the entire store. You could say, well, run this for every single SKU that we have available so that we know how to allocate our factories and warehouses accordingly. We can optimize our delivery schedules, so on and so forth. So by using machine learning, we can actually plot our historical data and get machine learning to plot that line of best fit and project that forward. So where does the machine learning part come into it? Because again, my little brother could probably plot this line. Well, machine learning is constantly learning from this data. So as we get more and more data incoming, the machine is trying to optimize this line to reduce the amount of error. So all the gaps between what it's predicting and what the actual value was, it's trying to reduce as much as possible without us having to explicitly tell it how to achieve that result. So as we get more data in, it's constantly adjusting, constantly working it out to improve this and reduce the errors that we see. But as we all know, occupancy isn't the only thing that influences sales volume. So what we can also do is then we can create new features, new inputs that would help us predict sales volume more accurately. So occupancy alone isn't going to do that. So what can we take into account? So these are some ideas I've come up with for today. So something else, temperature, maybe, if it's warmer outside, people buy more, but to what point? If it's 30 degrees, I don't know about you, I'm probably not going to be in Currys, I'm probably going to be at the pub or somewhere else. So to what level? If it's 0 degrees, I'm probably not going to head out and things like that. Promotion score I created, so I would argue that if there's more promotions in Currys, more people are going to come, they're going to buy more because things are on offer. If you think of your Black Fridays, your Cyber Mondays, things like that. So promotion score is a score from 0 to 1 that I've said what percentage of SKUs in the store are on a promotion. New product launch, again, is a new feature that I've thought, well, if the new iPhone 15 Pro Max or whatever it's called is coming out this week, we can probably anticipate more sales volume as well. So that's a simple 1 is yes, 0 is no. So you probably want to identify key SKUs in your data set and saying, if these new SKUs are coming out, you can probably anticipate more sales volume. So things like the new iPhone, a new Sony television, key SKUs within. If it's a new toaster, probably not going to be a key SKU. Sales staff as well. So I've worked in retail before and I've seen queues of people waiting to be served and they eventually just leave. So, you know, how many sales staff have we got rotated in for Saturday? If it's 1, we're probably not going to sell as many as if we had 10, but what is the cut-off? Day of the week as well, so people probably buy less Monday, Tuesday, Wednesday, probably buy more throughout the rest of the week. So Saturday, Sunday, that's probably the day you're looking at. And by taking all these 6 different input variables into account, you can then train your machine learning algorithm to ultimately predict your sales volume. So then when I've got new data and it's learned from this historical data going back years or months or whatever it is, whatever's available, you can say, right, I think this week we're going to have 100 people, it's going to be 20 degrees according to the weather, we've not got that many promotions on, there's no new product coming out, we're going to have about 5 people and it's going to be a Saturday. So taking all that into account, machine learning and AI, what is the sales volume going to be? This will be it. So essentially what you can do is then plot it on the graph. So the red line indicates ideal, so where actual and predicted equals. So essentially what the machine learning is trying to do is trying to optimize it so its predictions get as close to the red line as possible. Again, the whole beauty of AI and machine learning is I don't have to explicitly tell it how to achieve that objective.